Okay, so in some sense, we're looking at this model backwards. If I go back to my picture here, we looked at how matching takes place. Okay, we just looked at the matching function about how given Q and A, given the number of workers in the labor market and the number of firms in the labor market, what proportion of each will match. Okay, so we looked at this matching function. Now we're going to look at, given that matching function and the other variables in the model, how Q is determined and how A is determined. So put another way, how rational consumers will choose to enter the market and how rational firms will choose whether or not to enter the market. So we're going to start with firms. So we assume here that firms pay some cost, K, to search for a worker. So if I'm a firm and I enter the labor market, I have to pay this cost, K. And you can think of this as being like the cost of putting out a wanted ad, or the cost of everything that goes along with hiring. So interviewing, for example, is costly. The actual, having people sit around a boardroom and decide who to hire is costly. So it's a costly process to look for a worker. That's the argument. And so therefore, firms must pay this cost K to enter the market and search. Okay? It's a costly activity. If they meet a worker, if the firm meets a worker and matches, then they produce amount Z. This is like the productivity of the firm is Z. And they must pay that worker the market wage W. Okay, so they produce Z, they pay the worker W. That's if they match. Now we have this concept of free entry. So remember I said there's an infinite number of possible firms who can freely enter the market at any time to search for workers. Okay, this is what we call free entry. At any time, freely, any number of firms can enter the market. So you might say, okay, well, when will a firm want to enter? And the answer is, well, it'll want to enter if it expects to make positive profits from searching for a worker. Okay, I'm going to enter the labor market and search if I think that it will yield positive profits on average. So what are expected profits of the firm? Well, if I enter, I have to pay this cost K no matter what. Whether I meet a worker or I don't, I have to pay this cost K. If I do meet a worker with probability PF, okay, that's the proportion of firms who meet a worker, so it's also the probability that I'll meet a worker. I produce Z and pay W, so my kind of profit is Z minus W. Okay? There's also a probability 1 minus PF that I don't meet a worker, which means that I make nothing. Okay, I don't produce, and I obviously don't pay a worker W because I'm not producing. And so now let's just rearrange this. Okay, so this is our free entry condition, or that is, this is our expected profits. Okay, so first we can get rid of this term on the right. Okay, this is just multiplying 0. And now let's substitute what we know this PF to be. Okay, we worked it out in the previous section. It's just the matching function evaluated at 1 over j and 1. Okay? Now, imagine that expected profits from searching are greater than 0. Okay? I, as a firm, look at the market, I look at these values, and this is greater than 0. I expect that by entering, I will make some profits. Well, then firms will enter and search for workers. This is what we said, right? But notice what happens. When I enter, I increase J. Okay, when firms enter, there are now more firms looking for workers. But notice that that decreases my probability of finding a worker. Okay? If there are now more firms looking for workers, then each firm itself is less likely to find a given worker. Okay? If there are 50 firms looking for a number of workers, they're more likely to find a worker than if there are 100 firms looking. And this leads to a decrease in profits, expected profits. And why is that? Well, it makes sense, right? If there's now a lower probability of me meeting a worker, then there's also a lower probability that I'm going to get this positive profits from producing. And so all else equal, that leads to a decrease in expected profits. So what does all this mean? Well, it means that therefore firms will continue to enter until expected profits are zero. Okay? So if expected profits are greater than zero, then firms will enter. They'll increase J, which lowers the probability that any of them will actually find a worker, and therefore will decrease their expected profitability. And this same logic holds true as long as this is greater than zero. If it's less than zero, we go in the opposite direction, right? If it's less than zero, then firms will exit. J will go down. This will mean that any firm is more likely to meet a worker, and therefore expected profits will go up. The only time where this isn't changing, that is, where J isn't changing, where firms are neither entering nor exiting, is if expected profits are zero. And so that's what we have here. Okay, so the free entry condition itself says that expected profits must be zero. That's the free entry condition. Because of free entry, firms will enter until expected profits are zero. So let's just plug in what we know now. So this is the exact expression we had for expected profits on the last slide. Move the k to the other side, and then rearrange. So divide everything by z minus w, and we get the following. This is our free entry condition. And what's important about this is what's going to determine J in the model. Okay, this is what's going to determine the labor market tightness, the vacancy rate, J. Why? Because so firms are always going to take this Z, W, and K as given, and given those, there's one value of J that's going to make this left-hand side equal to the right-hand side. Okay? Any other value of J will lead firms to either enter or exit. That's what I write here. If we're not at that value of J, the one that leads to this equality, firms will either enter or exit for the reasons we talked about on the last slide. So that's what's important. This free entry condition will determine J for us. And so graphically, what does it look like? Well, here's the matching function evaluated at 1 over J and 1. Okay, that was the left-hand side here. And then for give me any K, Z, and W, and I can look on this line to figure out what the J is that leads to the equality of the matching function here, evaluated at 1 over J and 1, and K over Z minus W, i.e. leads to this free entry condition to hold. And so just if you think about it, just do one quick experiment here. Imagine the cost for searching goes down. Okay, it's now less costly to search. Well, that means that my expected profits will go up, right? If expected profits go up, then it's going to lead firms to enter. And so we'll end up at a point on the line further to the right and down, like this. And we'll see kind of in real experiments. I'll show you other examples of this. What about workers? Okay, so first we just looked at how firms rationally decide whether or not to enter, and it's based on this free entry condition. Enter if profits are greater than zero, exit if they're less than zero, do nothing if they're equal to zero. Okay, so workers are going to do something similar. They're also going to compare their payoffs between being in the labor force and not being in the labor force. So first let's think about what are the payoffs to being in the labor force. Well, if I'm employed, I receive wage W. Okay, so if I match with a firm, the firm will pay me the wage W. If I don't match, okay, if I'm unlucky and I go into the labor market and I don't match, we're going to assume that workers receive some unemployment benefit B. Okay. So what's the expected payoff of searching? I.e., what's the expected payoff of being in the labor market? Well, with the probability PC that I match, I get wage W. And with the opposite probability, 1 minus PC, I don't match and I get the unemployment benefit. And first I'm just going to rearrange this. Okay, you'll see why later, but these two expressions are just the same, okay? And then let's plug in our expression for PC in terms of the matching function. And we get the following. Now, importantly here, the payoffs to being out of the labor force are heterogeneous. That is, different workers value being out of the labor force differently. Okay, there could be many reasons for this. Okay, it could just be preference. It could be that when I'm out of the labor force, I can do more home activity, home production as it's called, the things that are necessary to do out of the home, or at home, sorry. But importantly here is that people value being in the labor force differently, or being out of the labor force differently. Okay, some people really value being out of the labor force and others don't. And so why is this important? Well, we can say that workers will want to enter if the value to being in the labor force that we just found here is greater than the utility of being out of the labor force. And I said that this utility of being out of the labor force is heterogeneous. It's different across workers. And this actually leads us to what determines the labor force, okay? And it's given by this line V of Q. And so let me be specific about why this holds, okay? This tells us, because the line is upward sloping, this tells us that if the value to being in the labor force increases, there will now be more workers for whom the value of being in the labor force is greater than the value of being out of the labor force. Okay? As I move up this line, as I increase the value of being in the labor force, there's now some workers who before did not want to search for work, now want to. Okay? And so that's why you get this upward sloping line. And again, it's kind of intuitive, right? The higher is my expected payoff from searching, the more people we're going to expect to do it. Right? The higher is the payoff to being in the labor force, the more people we're going to expect to be in the labor force, all else equal. The more people we expect to get a higher payoff for being in the labor force than being out of the labor force. And that's why we get this upward sloping curve called V of Q. So it takes the value of being in the labor force and gives us a value for Q, the labor force.